Hello and welcome back to Clarkenomics. In this video, we're going to learn about the demand curve. So before we get to actual demand curves and graphing anything, we're first going to look at the idea of a demand schedule. Now, this is not a schedule like time or anything like that. Instead, we're just looking at somebody's consumption decisions. So let's keep this as simple as we possibly can at first here. Let's imagine one consumer and one product only. So we're going to create a demand schedule about something like John's demand schedule for soda. One person, John, one product, soda. Easy enough. Now, here's how to read this table. This is going to seem a little bit unusual, but the way we're setting it up is going to help us later on down the road. At different prices, this is the price per soda, John is going to have what's called a different quantity demanded of sodas. So let's look at the information in the table. When sodas cost $1 a piece, John says, wow, that's a low price. I'm going to buy 15 sodas. Each one costs $1, so John's going to buy 15 sodas. When sodas cost $2 a piece, John doesn't want as many sodas anymore because the price of each soda is now higher. That's a disincentive to him. That means he's only going to now buy 12 sodas at that higher price. If the price is $3 per soda, John only wants 9 sodas. If the price is $4 per soda, John only wants 6 sodas. And if the price is the highest price on our table, $5 per soda, John is only going to buy 3 of them. So the way to look at this in terms of variables is price is going to act as the independent variable, meaning that's the thing that changes the other thing, right? That means the quantity of sodas demanded, that's the dependent variable. How many sodas John wants to buy is dependent upon the price of each soda. So that's how to read a demand schedule. Now, creating a demand curve is no harder than just taking the information from the table and plotting it on a graph. But one thing that we do have to set up real quick are the axes, because this is going to strike some people as unusual, but this is how economists do it. We're going to take quantity demanded, which is the dependent variable, and we're going to put that on the x-axis. Again, typically the dependent variable usually goes on the y-axis, but when we set up these graphs, we're going to put quantity demanded on the x-axis. On the y-axis, this is now where we're going to put the independent variable, which is price. So price is always going to go on the y-axis, and quantity demanded is going to go on the x-axis. And we're going to just title this thing John's demand for soda. So that's the important thing to remember. Price on the y, quantity demanded on the x. And if you don't want to write out quantity demanded every time, usually what we do is we just do an uppercase Q and then a subscript uppercase D. You can see it right here, QD, quantity demanded. It's a little bit faster to write. So let's plot some points. When the price of a soda is $5, John only wants 3 sodas. That's this row of information plotted right here. 5, and 3. Now, when the price of a soda is $4 per soda, John wants more sodas. He wants 6 now. And we can just keep plotting all these rows of information. Again, price is $3, he wants 9. $3, 9 sodas. And that's going to give us a relationship that looks like this. It's a downward sloping line. And this is what we call a demand curve. So demand curves are always downward sloping in the real world. And the important thing to remember here, you have to be very careful about this, is remember that quantity demanded, which we're going to treat as the dependent variable, is on the x-axis, and price, which we're going to treat as the independent variable, is on the y-axis. So if you remember that, you're less likely to get turned around. So let's talk about the slope of the demand curve, this negative relationship, right? Why is a demand curve downward sloping? Well, there's a couple of big reasons. The first one is the substitution effect. So in a previous video about optimizing consumption, I mentioned that the substitution effect goes as follows. When a product's price rises, the marginal utility you get per dollar spent on that product decreases, because essentially you're making a larger denominator and you're not changing the numerator. Marginal utility is staying the same, but if the price is bigger, that's going to lead you to a lower number. So what that does is it makes somebody buy something else instead, right? So for instance, with the graph that you see on the right here, if the price of chocolate rises from $3 up to $5, the marginal utility per dollar from chocolate is actually going to decrease, which is going to make this consumer go and buy something else. I don't know what, but they're going to buy something else. That's the substitution effect. When the price of a good rises, you don't want as much of that good. You'd rather now spend your money on something different. The other effect is called the income effect. When a product's price rises, what that means is your purchasing power has decreased. If the product is more expensive, you can't buy as much of that thing anymore. So if you think back to another video about budget constraints, that's how that works, right? If the price of a good rises, you can't buy as much of the good anymore. So there you go. So if the price of chocolate rises from $3 up to $5, the quantity demanded will fall from 8 down to 5 because, well, they can't buy as much chocolate with their income anymore. So all of this put together creates something that we in economics refer to as the law of demand. And it's not like a law like it's written somewhere in the books, but it's just how things work kind of law. So here's the relationship. You can see it right there in the graph. When the price goes up, quantity demanded goes down, right? Price rises from 3 up to 5, quantity demanded falls from 8 to 5. Price goes down, quantity demanded goes up. If we were to reverse this relationship and say the price falls from $5 down to $3, the quantity demanded will rise from $5 to $8, right? So that's the idea. It's an inverse relationship. When one goes up, the other goes down, and vice versa. So the slope is negative for demand curves because of that inverse relationship, but it's not necessarily constant. So as you can see from the demand for chocolate curve right here, this is not a constant slope, right? It's more of a curve shape. So the slope varies along the demand curve. Now, I'll say this, and economists and probably all economics teachers will do this. They'll use the terms line and curve kind of interchangeably. So you might see a demand curve that's just like a straight linear line. Don't get too hung up on that. That's just kind of how we shorthand talk about these types of things. But the important thing to remember about demand curves is they are always downward sloping. So there's an inverse relationship with price and quantity demanded. When one goes up, the other must go down. So that's why a demand curve looks the way it does, and those are some basic features of how demand curves work. Thanks for watching.